Assalamualaikum and a very good day. My name is Siti Naqibah binti Kamarudin. I am from Faculty of Civil Engineering, University Technology Malaysia, UTM. Today I'm going to present my paper entitled Comparison of Performance between Hot and Warm Mixed Asphalt as related to Compaction Design. Introduction. Hot mixed asphalt HMA is a conventional mixture to construct asphalt pavements, but nowadays all agencies are starting to acknowledge the importance of sustainability in road construction, so that warm mixed asphalt WMA is one of the strategies to achieve the sustainable construction. WMA technology could reduce carbon footprint and emissions by lowering the temperature during production and construction, and also provide other advantages compared to HMA, such as lower cost, better performance, and healthier environment. In order to enhance the newly laid flexible pavement, proper compaction is crucial. Appropriate temperature during compaction is very important to provide the strength of the pavement. The strength could be attained by increasing the pavement density to withstand the load of the vehicles and the weather. Therefore, measuring the cooling rate is one of the suitable methods to determine the ideal compaction of mixture. Instead of mixture temperature, there are other parameters that can influence the cooling rate of the asphalt mixture, such as temperature of the existing layer, compaction process, and weather. These factors affect compaction process for the pavement, which is one of the most important part for road construction. Basically, low pavement density could also affect the strength and cause shorter lifespan and rutting. Therefore, this study is very important to investigate the performance between hot and warm mixed asphalt related to compaction design. Okay. Literature review. D'Angelo et al. 2008 stated that WMA is a technology that allows reduction in the temperature at which asphalt mixture is produced and placed. It is produced by adding either waxes, asphalt emulsion, or sometimes even water to the asphalt binder prior mixing, and the temperature of WMA production is normally ranges from 100 to 140 Celsius, and which allow longer haul distance and cold weather pavement and healthier environment in terms of reducing of fuel consumption and emission. WMA has found to improve the performance in terms of minimizing the thermal crack, block crack, and oxidative hardening, which stated by Hurley and Powell 2005, and aggregate coating as a result of lower asphalt binder, which stated by Abdullah et al. 2014. For this study, we are focused more on Seca base, which is Olivero Rossi stated that Seca base is one of the common additive used for WMA. This additive improve the workability of bituminous mixture so that it can produce and pave at lower temperature than standard HMA without any process modification or loss of mechanical properties. Okay, factors that influence performance of road construction. There are two main factors. First, temperature, and second one is compaction. Frank et al. 2012 stated that the temperature of the asphalt mixture is important for better final quality performance, which is cooling rate is one of the suitable method to determine the optimum temperature of compaction by measuring the density after every roller passes. For compaction, it will affect the final quality layer because compaction is the last activity before the road is open for the public use, which is also stated by Frank et al. 2012. And viscosity of the asphalt mixture is influenced by the different techniques for WMA, but on the other hand, the viscosity will increase again when the temperature of mixture is lower. In order to obtain high density, optimal compaction should be reached. Okay, benefit of WMA for environmental. Timothy et al. Stated that it allows asphalt plant mixing to be produced at lower temperature, which is it will reduce the emission of carbon dioxide emission and greenhouse gases by consuming less energy compared to HMA. For paving, James and James 2010 stated that if WMA mixes are produced at normal operating temperature, it will allow longer haul distance and a longer construction season. And the last one is for economic. Abdullah et al. 2014 stated that it depends on the type of energy used during production process. the type of gases, pollution, and the maintenance cost of asphalt plant. Okay, this issue in WMA. Rotting resistance performance is the major issue in WMA. Lowering the mix temperature in drying the aggregates and in the plant mixing could potentially cause WMA to be more susceptible to moisture damage and rotting. The in-service rotting potential of some WMA products can be increased because generally void content in WMA is lower than HMA, as WMA have a good workability in some product of WMA, and together with a less oxidative hardening of the binder throughout the production process. Despite that, it can also conduct to an increased durability. This one is research methodology. For this study involves several tests that been conducted during construction and at laboratory work utilizing HMA and WMA using silica base as additive and asphalt binder type acting to 100. Table 1 shows the details of mixture design, which is HMA have 3 sections A, B, C, and WMA also have 3 sections D, E, F, and number 1 represent normal lay and number 2 represent double handling. Okay, for findings, table 2 shows that WMA premix achieve higher maximum density during compact compared to HMA premix. Concurrently, WMA has smaller slope graph of cooling rate than HMA. It can be summarized: temperature of WMA mixture decrease slowly but still provides higher density and keeps increasing. Different with WHMA, where the slope of graph is higher because of the temperature of HMA mixture decrease quickly, but when the compaction is completed, the density achieved decrease. In nutshell, WMA mixture provide better cooling rate during compaction and provide higher density compared to HMA. The next one is table 3 shows that WMA premix has higher degree of compaction DOC than HMA and exceed minimum requirement of 98%, which is from JKR specification, except section F. Concisely, WMA has higher workability of compaction compared to HMA. Next one, figure 1 plots the performance of coring samples after a month and 4 months. The graph demonstrates that after 4 months, the residual modulus value is increasing from a month for both HMA and WMA. The residual modulus was decreasing as compaction effort was decreased. High residual modulus at 25 Celsius shows that the mixture is more susceptible to fatigue crack. Mixture at section A and mixture at section D obtain the highest residual modulus for HMA and WMA respectively. In overall, this test concluded that HMA are more susceptible to fatigue cracking but less susceptible to rotting compared to WMA. Okay, as the questions for this study, the performance of WMA has been compared to the HMA. First, HMA has higher rate of cooling than WMA. Second, WMA has higher DOC compared to HMA, which indicates better workability in compaction. Third, WMA are more susceptible to rotting but less susceptible to fatigue cracking compared to HMA. That's all for my presentation. Thank you.